How the ISA shaped modern instrumentation, the story behind the symbols. In these dynamic times when technology evolves rapidly, it's vital to recognize the foundation laid by the ISA and how it continues to impact modern industries. By understanding their legacy, engineers today can appreciate the clarity and efficiency brought to complex systems. Moreover, the ISA's commitment to continuous improvement encourages a culture of innovation that reflects the ever-changing landscape of automation and controls. Each diagram we encounter not only represents data, but tells a story of a collaborative journey towards standardization and clarity in engineering practices crucial for the future of technology. While the ISA has made significant strides in promoting standardization, the journey doesn't end here. As industries continue to integrate advanced technologies like IoT and AI, the need for adaptable and forward-thinking standards will grow. Crash Course. Instrumentation, Saturday History Special. Ever looked at a piping and instrumentation diagram and thought, how did we all agree on what these symbols mean? Today, we're going to uncover the story behind the ISA and how it standardized the visual language of automation and controls. Instrumentation, quattro control systems, Hakart instrumentation tech, naht INE. In the early days of industrialization, every company had its own way of drawing systems. One refinery's flowmeter might be a square, another's a circle, and yet another's a triangle. Imagine the confusion for engineers moving between companies. Fun fact. Before standardization, it wasn't uncommon for new hires to spend weeks just learning how to read their company's custom symbols, even for simple systems. Birth of the ISA. Enter 1945. The Instrument Society of America is founded in Pittsburgh, Pennsylvania. Their mission? To create a common language for the growing fields of instrumentation and controls. They started gathering experts from industries like oil refining, chemical manufacturing, and power generation. Cool history. The first ISA meetings were so critical that attendees had to pass security checks during World War II. Industrial sabotage was a real fear. The first standards, one of their first major goals, developed standard symbols that everyone could use. Circles for instruments, diamonds for computer functions, squares for final control elements like valves. These choices weren't random. They were carefully selected for clarity and consistency. Interesting detail. The circle symbol was chosen for instruments because it resembled the dials and gauges that dominated early control rooms. Basic ISA symbols. They also introduced letter coding. T for temperature, F for flow, P for pressure, and so on. This system became the foundation for ISA 5.1, the standard for instrumentation symbols and identification. First published in 1949 and refined many times since. Historical insight. The standardization of letters and numbers made it easier to scale systems, like adding a second pressure gauge without total redesign. Then early versus modern diagrams. With the ISA standards in place, technicians, engineers, and designers could now read systems the same way, whether they were in New York, Houston, or overseas. It revolutionized troubleshooting, system design, and training across industries, marking a big change from earlier when techs had to decipher company-specific symbols and schematics. Fun comparison. A 1950s process drawing could fit on a napkin. Today's smart P&IDs can have thousands of points and still remain clear thanks to standardization. Yet modern digital twin graphics. Today, the ISA continues to evolve with digital technology. Smart P&IDs, digital twins, and Internet of Things systems all owe their clarity and structure to those early ISA efforts. Modern cool fact. ISA standards now influence cybersecurity practices for industrial networks through initiatives like IEC 622443. Part closing. Modern P&IDs. The next time you see a perfectly clear schematic, remember, it didn't happen by accident. It was built on decades of collaboration, innovation, and the drive to make complex systems understandable to everyone. Also, it is incumbent on all techs to continually improve themselves and the drawings they work with. Final call to action. If you found this fascinating, make sure to like, subscribe, and hit the bell so you never miss a dive into the history behind the tech we use every day. Instrumentation nash pa control systems, instrumentation tech machine INE.